Okay, so we've already learned the ins and outs and upside downs of molarity problems and how we use them. So now we got to look at another form of molarity problem called ion concentration. Ion concentration takes into account what the concentration is of each of the ions in solution. Our problems look like this. What is the concentration of each ion in a 0.5 molar solution of cobalt nitrate? So we're looking to find out what is the concentration of each of these ions. We learned when we did our stoichiometry, when we did s'mores, that we could have one s'more, but that would be made up of 2 graham crackers, 1 chocolate piece, and 1 marshmallow. And so we learned that 2 plus 1 plus 1 equaled 1. And so our math is going to work the same way here because it's not the math that we're used to. So if I have this and it's aqueous, which means it's in solution, it's really ions. And so if I break this apart, and we learned this when we did precipitate reactions, it's going to be CO plus 2 NO3 minus 1. If I have 0.50 molar of all of this, that means that I have 0.50 molar of cobalt. But because of the stoichiometry here, because of when I break it apart, there's 2 nitrates for every 1 cobalt nitrate, it means that I have twice as much of that. And so in this case, I have 0.5 times 2, where I have 1.0 molar of NO3. And I know this is hard for people to see and to understand, but think of it much like you did the s'mores. 2 graham crackers makes 1 s'more. 2 nitrates makes 1 cobalt nitrate, and that's how we end up with having twice as much. It comes from that stoichiometry in that reaction. Let's take a look at another one. What is the concentration of each ion in a 0.25 molar solution of aluminum sulfate? Well, the first thing that you have to do is you have to be able to write the formula for aluminum sulfate. And so let's go ahead and see if you can do that. So pause the video for a second and see if you can. Okay, did you get Al2SO4 3? If you did, then you're in good shape because you're going to have to write formulas in this unit again. We're never going to let go of that. And so now we need to break this apart. And so we're going to break this apart into 2Al plus 3 plus 3SO4 minus 2. So I have 0.25 molar of aluminum sulfate. How much of each of the other ones do I have? Test yourself and pause the video and see if you can get it correct. Okay, did you pause the video? I hope you did, because this is the best way for you to see if you understand this. Because if you do it correctly without me telling you, then you know that you have a good grasp on it. My stoichiometry here is 2, which means I have twice as much of this, so I have 0.50 molar. My stoichiometry here is 3, which means I have 3 times as much, so I have 0.75 molar of SO4. Let's take a look at another one. How many moles of Ag plus ions are present in 25 milliliters of a 0.75 molar silver nitrate solution? Well, now I'm not given, it wants to know how many moles I have. So we have to do some additional steps here. So again, we have our AgNO3, and we have to see how it breaks apart. Well, it breaks into Ag plus NO3. This is a nice straightforward one, because if I have 0.75 molar here, and these are all 1, I have 0.75 molar of Ag and 0.75 molar of NO3. And so it wants to know how many moles are present. So molarity is equal to moles over liters. I have milliliters here, so that's not going to be useful, but I have 0.75 molar, and it's some sort of moles that I'm solving for, and my liters are 0.025 liters. So if I go ahead and I multiply those two numbers, I end up with 0.0188 moles of any of them, because they're all 0.75. So in this case, I can say that it's AgNO3, or because they're the same, I can say it's 0.01, oops, that's not very good writing. I can say it's 0.0188 moles of Ag. Let's take a look at one more. Calculate the number of moles of Cl ions in 1.75 liters of 1 times 10 to the negative third molar AlCl3. Again, this would be a great one for you to pause and see if you can do it on your own. It's going to be a little bit different from the last one. Okay, did you pause? Let's see. So we have AlCl3, which is going to break apart into Al plus 3 Cl minus. So I'm looking for the moles of chloride ions. Well, I have 1.0 times 10 to the minus 3 molar solution. It's a 1 to 3 ratio, which means this is 1.0 times 10 to the minus 3 molar. But this is 3 times the amount because there's 3 times as much. So 3.0 times 10 to the minus 3 molar of chloride ions. It wants to know the number of moles, and so my problem's not done. Molarity is equal to moles over liters. Molarity is equal to, I have 3.0 times 10 to the minus 3 molar is equal to X number of moles over 1.75 liters. So now I can go ahead and solve that. And I get 0.00525 moles of Cl minus. And so it's just taking into account this ratio of having 3 times as many chloride ions as I do aluminum chloride.